All right, hey again, honors chemistry. So the last question on this worksheet that we're going to do together is a bit more complex, but it's going from grams to moles. So it says neuroscientists believe that the only chemical in the chocolate that may have a feel-good effect on the human brain is phenylethylamine, PEA, which is right here. Although the PEA in chocolate occurs naturally, PEA can be made in the laboratory by the following reaction. If I have 1 mole of ammonium formate and I react it with 1 mole of acetophenone, I'll get my 1 mole of phenylethylamine, carbon dioxide, and water. And let's just work under the assumption that this equation is balanced, and I'm going to say that it is. Okay, so the equation is balanced. Everything is a 1-to-1 mole ratio. I also put the molar masses if you want. I'm going to rewrite it. It says how much PEA can be made from 75 grams of ammonium formamate and 125 grams of acetophenone. I know this is a limiting reactant problem because they give you both amounts of reactants. Both amounts of reactants. All right, just as a note. And it says what mass of the excess remains. So let's figure out how much PE I could do. I'm going to rewrite this with a BCA table, or you could do it just like right underneath. It's fine. C8H11N plus CO2 plus H2O. Alright, so for my BCA table, I have to convert any and everything to moles. BCA. So I have 75 grams of the ammonium formamate, and the molar mass I looked up was 63.055. 63.055 grams. So I'm going to say CH5NO2 grams per mole CH5NO2. Remember, grams divided by molar mass is equal to moles. So 75 divided by 63.055, and I get 1.19 moles. 1.19 mole. That's going right here. 1.19 mole. And then for C8H8, I have 125 grams. I'm going to call it aceta. And the molar mass I looked up is 120.15. 120.15 grams per mole of aceta. And if I do that math, 125 divided by 120.15, I get 1.04 moles of aceta. Okay, 1.04. And the question's asking about this phenylethylamine. So I'm going to put the longer line here, and I'll ignore my CO2 and my H2O for right now. It's not asking about it. I'm going to put my longer line here, and I'm going to see how many moles each of my reactants could give me for my products. Well, everything's in a 1-to-1 mole ratio, so it's going to be the same. So from CH5NO2, I should get plus 1.19 moles. From C8H80, I should get plus 1.04 moles. And then my procedure is choose the lowest moles of product made. 1.04 plus 1.04 moles of C8H11N. Okay? This is my theoretical yield, and this is how much I should get. The question's asking how much PEA can be made. It wasn't specific, so I could just say this is how much is made. 1.04. Then it says what mass of the excess reactant remains. So it's asking for what mass of the excess reactant. So now I'm going to work backwards. If everything's in a 1-to-1 mole ratio, if I'm making 1.04, I'm going to only use 1.04 moles of this. That's all of that. And since this is also 1-to-1, I'm using 1.04 moles of that. And if I do my math correctly, 1.19 minus 1.04, I get 0.15 moles in excess of CH5NO2. And then it wants the grams, so if I have my moles of excess, I have to multiply times the molar mass. So 0.105 moles times, the molar mass is 63.055 grams per mole. 0.15 times 63.055, and I get 9.46 grams are in excess. Are in excess. right? So I have 0.15 moles are in excess, which if I multiply by the molar mass, I get 9.46 grams are in excess. All right, so I've made a video on every one of the short questions here. So basically, our procedure and method is using stoichiometry and mole-to-mole ratios. Give me 2 moles of my product now, and then I'm going to choose whichever moles is the least amount or my lowest moles. That is what we're going to use for right now, and we will definitely talk more in class like why I do this. There's another method that we could use, but in my videos, I want to stick with using or choosing my lowest moles of product. Why? Because the questions always ask for what amount of product am I making. So figure out how many product I can make from both reactants and then choose my lowest one instead of trying to fit with and work over here. All right, so that is our new procedure for limiting reactants. Hopefully these videos would be helpful to kind of guide you and help you understand how to do limiting reactant problems in stoichiometry.